Now, communication within a distributed system can happen either asynchronously or synchronously. Now, we're also going to learn about the different types or rather techniques that distributed system use when they're communicating. That is blocking and unblocking techniques. So if you're interested in this kind of topic, kindly hang on until the end of this particular video so that you learn more about how communication happens within the distributed systems. Happy learning. Hi Lana, welcome once again to Learner's Coach. So today we are going to look at how two processes communicate in what we refer to as inter-process communication. So this communication happens synchronous and asynchronous. So we are going to understand what do we mean by synchronous and synchronous communication in distributed systems, right? So we're going to look at two processes, or we are going to assume that you have two processes communicating to each other. As you are aware, interprocess communication within any distributed system happens by sharing of messages, yeah, from one process to the other, right? So it can either happen synchronously or asynchronously. So the concept of synchronous communication is where the process or the two processes both can be able to send and receive in blocking operations. So that means a particular process can allow the other process to either receive, and the other process can allow the other process to send, right? So the other thing that you need to know is this particular asynchronous communication, whereby the use of the send operation is non-blocking and the receive operation can have either blocking and non-blocking variants. We take a look at two examples of protocols that use synchronous and asynchronous communication. A good example of a protocol that uses synchronous way of communicating is the transmission control protocol, right? The TCP. And asynchronous is the one we refer to as the user datagram protocol. So we're going to understand how this operation occurs, right? So we have agreed that two processes communicate by passing of messages. So this particular passing of messages could be either blocking or non-blocking. So what is really blocking in synchronous? Yeah. So the ability of a particular process, yeah, to block a particular blocked a particular sending of message before it is received is what we refer to as a blocking send. And of course, you have blocking receive. That means that the receiver block this particular communication channel until the message is fully available. So these are two concepts that you need to understand. Yeah, blocking send, you block, the process blocks the sending process until the message is received, right? And the blocking receive, the receiving process actually blocks the communication channel until the entire message is received. Also, we have non-blocking. Non-blocking is actually to allow free flow of information. So non-blocking is normally considered when asynchronous communication is taking place. We have non-blocking during the transmission of the message, yeah, and of course we have the non-blocking during receiving of this particular message. So a particular process can either decide to block this particular message, or it can also decide to non-block. So these are two parameters that is normally used when two distributed, or when communication is happening within a particular distributed system. So it's not really natural that for a sender is just to block, right? So it can send several messages to multiple destinations, right? But also the sender usually expect acknowledgements of message. So during synchronization, we actually borrow the concept of windowing, where the sender has to send some alert message to the receiver that it is sending a particular message. Then the receiver, upon receiving the entire message, it sends acknowledgement that it has received that particular message properly. In case there is a failure, or in case the message was not properly sent, it can always issue an alert that the message was not received properly. So these are some way to understand how the various processes communicate within a distributed system. We also have other possibilities apart from just blocking and unblocking. Yeah, so we can have a possibility where both processes block the messages until it is received. Yeah, so this always normally occurs when communication link is unbuffered. For instance, there is no message queue, right? Now we also have other combinations. We have already looked at blocking send that happens within synchronous communication and blocking receive. We also have non-blocking send and non-blocking receive. Now these are not a typical way that processes communicate within a distributed system, but we have the typical way, right, or the most preferred way of communication, and that is the non-blocking send and blocking receive. Yeah, for instance, a server process that provides services and resources to other processes, it will need the expected information before proceeding. So that means if a particular process within a server actually wants to do it, to send that particular message, it will allow the server to receive other additional requests, yeah, but also allow the server to deal with one particular request through a blocking mechanism. So we have the event synchronization. Before these two processes communicate or share the message, they need to synchronize the operations, in that one side sends, then the other receives until all data has been sent and received. And this is typical of TCP, transmission control protocol. It normally provides this particular event synchronization before the communication happens. So when we talk about synchronization and asynchronization, we need to look at synchronization as a mechanism where communication channel is blocked, right, and before this particular message has been transmitted, and vice versa. So alternatively, the inter-process communication operations may occur through asynchronous, that what we refer to as non-blocking. So an asynchronous operation is issued by a process, will not block further processes, right? The processes will be considered free to proceed with this processing. So this is just what we have already mentioned, that asynchronous communication offers the non-blocking option. Non-blocking meaning that it allows the sending process to keep on sending, right? Then also it also allows the receiving process to keep on receiving. That is non-blocking, non-blocking. Non-blocking within the receiver side, non-blocking within the sender side. We also have the option where we have non-blocking and blocking. Let's see at this. Let's look at this particular diagram where we have synchronous send and receive. So the first diagram, as you can see, we have a key denoting the red cycle or the point as an operation, and of course we have the continuous arrow showing execution flow. Then we also have the dotted line, that means there's some kind of suspension, right? So let's understand how synchronous send and receive works. Now we have two processes here, processor 1 running on host 1 and processor 2 process 2 running on host 2. So when process 1 is sending a message, you can see it actually executes the non-blocking, yeah, no, it executes the blocking procedure. Blocking is seen by the continuous line, right? Then it blocks until the processor or the process 2 communicates or offers acknowledge, yeah, is when it resumes some kind of blocking procedure, right? Then on the at the second process, you can see there is a little bit of blocking that happens. Then it suspends the blocking, and then it allows the server to receive that particular message in a blocking mechanism. So this is where we have the operation of synchronous communication happening between two processes. So there's a blocking during the send, and also there's blocking during receive. So let's look at the second option, where we have asynchronous during send and synchronous during receive. In other words, we have non-blocking during send, and we have blocking during receive. So those are the two mechanisms that the two processes employ at this particular juncture. So asynchronous is a way that sending a process offers the non-blocking tactic. As you can see, there's some kind of continuous, yeah, line showing that the client is actually offering some kind of non-blocking. Then there's a blocking operation within the process 2. So we also have synchronous send and asynchronous receive, where we have the blocking being issued, and of course there's some kind of acknowledgement before the process 1 proceeds or resumes sending its message through blocking procedure. And of course we say we have non-blocking from the asynchronous side, where we have the process 2 receiving the message through synchronous operation. So we can go on and on trying to understand how this synchronous and asynchronous communication happens. All we need to know in summary is that synchronous offers an unblocking tactic, where it allows the sender of the message to send a particular message by blocking, right, its communication channel, and allows the receiver to receive that particular message. The other option is to offer asynchronous, right, asynchronous blocking, or what we refer to as non-blocking, where a particular process has the capability of either receiving multiple multiple messages, and of course also sending multiple messages. So that is all about synchronous and asynchronous communication within distributed system. So kindly check on our previous tutorials about communication or inter-process communication in distributed system. I've already shared the link. You can go through it. I've covered a wide variety of topics, right from understanding how inter-process works. We have also looked at how to employ the various tactics, such as remote method invocation and remote procedural call. So should you find this particular tutorial interesting or useful, always feel free to subscribe and share the channel with the rest of your friends. All right, thanks.